In the depths of the universe, there are places where all known laws of physics collapse, where time and space lose their meaning, and even light cannot escape. These are the universe's greatest monsters, its most insatiable predators. Their very name evokes a shiver: black holes. They are not just voids or darkness. They are where gravity declares its absolute victory, where matter is so densely packed and space-time so severely warped that they become a one-way waterfall, flowing inward only. The story of a black hole begins with the glorious death of a star and opens a doorway to the greatest mysteries of the cosmos. This strange idea began to take shape in the early 20th century with Albert Einstein's theory of general relativity. Einstein proposed that mass bends the fabric of the universe, what we call space-time, and what we experience as gravity is simply our motion through this curved fabric. Imagine placing a bowling ball on a stretched bedsheet. It warps the sheet, and a marble placed nearby rolls toward it. Shortly after this revolutionary idea, German physicist Karl Schwarzschild solved Einstein's equations and discovered a shocking possibility. If mass is compressed into a small enough volume, it could warp space-time so intensely that it would essentially puncture it. This would form a singularity, a point of infinite density. The idea was so bizarre that even Einstein was reluctant to believe his own theory could allow such a monster to exist. The term black hole wasn't coined until 1967, when physicist John Wheeler gave this unfathomable concept a name that would never be forgotten. A black hole is usually born in one of the most spectacular events in the universe: the death of a massive star. Imagine a star at least 20 to 25 times the mass of our own sun. For millions of years, it shines brightly through nuclear fusion reactions in its core. The outward thermal pressure from fusion balances the immense inward pull of gravity. But eventually, the fuel runs out. Fusion ceases, and balance is lost. With no more force to resist it, gravity wins. The star collapses inward in a matter of seconds. The collapse is so violent that its outer layers are blown into space in a massive explosion, a supernova. What remains, the core, continues to collapse. Gravity becomes so strong that it crushes even protons, neutrons, and electrons, squeezing them into oblivion. Several solar masses are compressed into the size of a city, a house, a pinhead, and finally into a point with mathematical zero volume and infinite density, the singularity. A black hole is born. To understand a black hole, we must know its anatomy. Its most important part is the event horizon, not a physical surface, but a boundary of no return. Think of it like the edge of a massive waterfall. If you're swimming upstream and strong enough, you can still escape before reaching the edge. But once you cross it, the current is too strong. There's no turning back. The event horizon works the same way. At that point, space-time itself is falling toward the singularity faster than the speed of light. Even light cannot escape. That's why black holes are black. Nothing, not light, not information, can ever return once it crosses that line. What would happen to an astronaut who falls past the event horizon? The answer isn't pretty. Spaghettification. The gravitational pull on their feet would be exponentially stronger than the pull on their head. This immense tidal force would stretch and thin them out until they are torn into atoms, into a long strand of cosmic spaghetti. Stranger still is time dilation. To an outside observer, the astronaut's clock would appear to slow down as they approach the event horizon. Their movements would become slower and slower until they seemed frozen at the edge forever. But from the astronaut's own perspective, time would flow normally, and during their short journey toward the singularity, they might witness the entire future of the universe pass by like a fast-forwarded film reel. Black holes aren't just small monsters born of stellar deaths. At the centers of galaxies lie supermassive black holes, with masses of millions or even billions of suns. At the heart of our own Milky Way is such a giant, Sagittarius A star. These titans are the hidden engines that guide the formation and evolution of galaxies. So when you think of a black hole, don't just imagine a void that devours everything. They are the tombstones of the mightiest stars, the universe's most extreme physics laboratories, the places where time and space collapse and science meets its limits. They are the universe's one-way doors, and the endless curiosity of what lies beyond.
The Door to Knowledge, presented by Toyer TV. Don't forget to take your place on this path of discovery and enlightenment.